Some nights the sky holds a kind of stillness that feels almost deliberate, as if the universe arranged itself very carefully into something soft. If this feels like a good place to rest tonight, you're welcome to stay. Now, let's drift. There is something quietly remarkable about silence. Not the absence of sound, but the kind of silence that seems to have weight to it. A presence. Scientists have spent a long time trying to understand it, and what they keep finding is something rather unexpected. Silence is not empty. It never was. In the earliest moments of the universe, long before stars, before planets, before anything we would recognize, there was a period scientists call the Dark Age of the cosmos. It lasted hundreds of millions of years. During that time there was no light, no heat in any direction a living thing might look. And yet the universe was not still. Hydrogen atoms drifted. Gravity pulled gently at invisible threads. Something was already preparing in the dark for everything that would come. Researchers have found that even in the deepest silence we can measure today, the silence of interstellar space between galaxies, it is never truly quiet. There is always a faint electromagnetic hum, a residual warmth left over from the very beginning that still travels through space in every direction. Scientists call it the cosmic microwave background. It is in a sense the oldest sound in existence, not a sound the ears can hear, more of a feeling, a whisper that has been travelling for nearly 14 billion years without stopping. It is passing through this room right now. There is something calming about that if you let it settle. The idea that the universe has always had something to say, and that it says it very quietly. Scientists suggest that one of the reasons human beings are drawn to silence, to dark rooms, to still nights, to the low hum of rainfall, is because the nervous system interprets quiet as safety. The brain tends to interpret the absence of urgent sound as a signal that nothing needs attention. Nothing needs to be solved. The body can afford to slow down, to soften. Researchers have found that exposure to quiet environments measurably lowers cortisol levels, the chemical the body produces when it is under pressure. In silence, the stress response begins to ease on its own without effort, without instruction. The body already knows what to do with quiet. It has always known. And yet silence is strange to many people at first. There's often a moment when the world goes genuinely still, where the mind reaches for something to fill it. A thought, a memory, a small worry pulled from somewhere. Psychologists often note that this is not a flaw in the way we think, it is simply the mind checking its inventory, making sure nothing was forgotten. And when it finds that everything is in order, that there is nothing requiring immediate attention, it tends to settle. It goes quiet too after a while, slowly, in its own time. The universe seems to work the same way. After the long dark silence of its early age, the first stars began to form. It happened gradually the way most beautiful things happen without announcement. Gravity gathered hydrogen into dense warm clouds. Those clouds collapsed under their own weight, and somewhere inside that collapse pressure and heat reached a threshold and something ignited. The first light in the universe appeared. Researchers believe roughly 180 million years after the beginning. 180 million years of preparation of silent arrangement before a single photon was released into the dark. There is something in that which feels almost patient. Neuroscientists have observed that the human brain, when it enters its deepest resting states, follows a similar kind of preparation. Before the transition into sleep, the brain does not simply switch off. It moves through stages. It quietly reorganizes. The regions responsible for attention and problem-solving begin to grow less active. The areas associated with memory and integration, the parts that weave experience into meaning, become more prominent. It seems that the mind uses its quiet hours to do something the waking day never quite allows to process slowly, to let things settle into their proper places. Sleep in this way is not an absence of thought. It is a different kind of thinking, a gentler one. Studies indicate that the brain clears certain metabolic byproducts during sleep's small molecular residues that accumulate during a day of active thought. There is an entire system in the brain only described in the scientific literature relatively recently that becomes more active during rest. It uses the slow rhythmic movement of cerebrospinal fluid to rinse the spaces between neurons. Scientists are still exploring exactly how this system works, but the early findings suggest something rather elegant, that the brain quite literally cleans itself while it rests. That the act of doing nothing is in fact doing something essential. The mind repairs itself in the dark. There is a particular kind of quiet that deepens after midnight. Scientists have noted that the natural world responds to it as well. Studies in acoustic ecology, the study of sound in natural environments, have found that the ambient noise of forests, rivers and coastlines measurably changes in the hours between midnight and early morning. The calls of certain birds cease, insects grow quieter. Even the movement of water researchers suggest carries a slightly different frequency in that stillness, as if the planet itself exhales when the day is done, as if the Earth too has been waiting for permission to rest. It may be that this is why a quiet room feels not just comfortable but almost necessary. The body recognizes this state. It has been moving toward it all day, waiting for the moment when the light dims and the sounds fall away, and the whole complicated world contracts to something small and manageable. A mattress, a blanket, the sound of your own breathing. Researchers have found that even the rhythm of breath changes as the body approaches rest. It slows. The inhale becomes slightly longer. The exhale follows with less effort. The pause between them, that small quiet interval between breathing out and breathing in, grows just a little wider, and in that pause the body is held, not tensed, not reaching, just held for a moment in the particular stillness that exists at the edges of sleep. The universe, scientists suggest, has its own version of this rhythm. The expansion of space itself is not uniform. It moves in large, slow pulses shaped by the distribution of matter and the pull of forces that are still not entirely understood. There are structures in the cosmos, vast filaments of galaxies stretching hundreds of millions of light years, that seem to breathe in a sense, to expand and contract along invisible lines. It is a rhythm so slow that no human lifetime could perceive it directly. But it is there in the data, in the quiet mathematics of the universe moving through its own kind of rest. Some things, it seems, are always in the process of settling. There is a word in physics: equilibrium. It describes the state a system reaches when its competing forces have balanced, when nothing needs to push harder in any direction, when the energy that once drove movement has found its level, and things can simply be without effort in the place they are meant to occupy. The mind has its own version of equilibrium, and what researchers keep finding quietly in study after study is that the conditions most likely to bring it about are not complex. They are simple: darkness, warmth, the absence of demands, the knowledge that nothing is required of you for a while. This moment right now may be as close as a person ever gets to that state. And there is something rather remarkable waiting just beneath the surface of rest. Something scientists have only recently begun to describe: the way the body does not simply stop when it grows still, but instead turns inward. Begins a kind of conversation with itself. One that happens in the space between waking and sleep, in the hours when the noise of the day has finally faded enough for something quieter to be heard. That conversation has been happening every night for as long as there have been people who needed rest. And it begins, as most things do, with the body already knowing what to do. What scientists have found when they study the brain in those first moments of genuine rest is something that looks less like shutdown and more like opening. The mind, when it finally stops organizing the day, begins to do something looser, something more like wandering. Researchers studying the neural activity of people drifting towards sleep have described it as a kind of gentle chaos, a soft, unstructured movement through memory and sensation, without direction, without purpose. Ideas appear and dissolve, a face, a colour, the feeling of a place you've not thought of in years. Psychologists often note that this drifting state, that borderland between waking and sleep that some researchers call hypnagogia, is not a transition to be rushed through. It is a state in its own right, a place where the mind moves freely without the weight of intention, where the ordinary logic of the day loosens just enough for something else to come through, something quieter, something that has been waiting patiently for the noise to stop. And what comes next as the body settles further into rest may be something the mind has always known how to do something. It learned long before we had words for it. There is a particular kind of knowing that has nothing to do with thinking. The body holds it. Not in the mind, not in memory, not in any place that can be pointed to or explained. It lives somewhere quieter than that, in the slow chemistry of the blood, in the temperature of the skin as it adjusts almost imperceptibly to the cooling of the room, in the way the muscles one by one release a tension they had been holding all day without ever being asked to. The body already knows it is night. What we understand so far suggests that this knowing is ancient, far older than language, far older than the first human being who ever lay down and closed their eyes. It is written into the biology of nearly every living creature on Earth. A timing system so reliable, so precisely calibrated, that scientists have spent decades trying to understand exactly how it works. And the more they learn, the more they find that the body is not simply responding to darkness, it is anticipating it. Researchers have found that the human body operates on an internal cycle that runs close to 24 hours, not exactly but close enough that it tracks the rotation of the Earth with remarkable fidelity. This system is governed not by a single clock, but by something more distributed. A network of timing signals that coordinate across organs, across tissues, across the smallest cellular structures. The heart follows it, the liver follows it, the lungs follow it. Even individual immune cells carry their own internal sense of time, adjusting their activity depending on where the body believes it sits in the cycle of day and night. Scientists call it the circadian rhythm. But that name, clinical and precise, perhaps undersells what it actually is. It is in a sense the body's relationship with time, a quiet conversation between living tissue and the turning of the planet that has been going on unbroken for hundreds of millions of years, long before electric light, long before glass windows and sealed rooms. The body learned to read the world through the quality of light alone, not its brightness exactly, but its colour. The light of early morning carries more blue. The light of late afternoon shifts toward amber and red. And as the sky deepens into evening and those warmer wavelengths fade, something in the eye, a particular type of cell that scientists identified only relatively recently, distinct from the ones used for seeing, sends a signal inward, not to the visual cortex, to the brain's internal clock. That signal says it is nearly time, and the body begins quietly to prepare. Evidence suggests that the drop in core body temperature that accompanies the approach of sleep is one of the most reliable markers of the whole process. The body sheds heat through the hands, through the feet, through the skin of the face, as a way of initiating the cooling that sleep requires. Researchers have found that warming the hands and feet, even artificially, can accelerate the onset of sleep. The body reads the warmth at the surface as a sign that the internal temperature is falling and responds accordingly. It is a mechanism that has nothing to do with intention. It simply happens the way most of the body's most essential work happens below the level of awareness, in the quiet dark of its own interior. There is something almost generous about that. The body doing its most careful work precisely when the mind has stopped paying attention. The hormone that most people associate with sleep, melatonin, is not strictly speaking a sleeping drug. It does not force the body into unconsciousness. It does something more subtle than that. It is a signal, a chemical message that the brain begins producing as darkness gathers, releasing it into the bloodstream in a slow rising tide. And what that message says to every organ and tissue that receives it is simply, night is here. The day is over. You can begin. Neuroscientists have observed that melatonin production is suppressed by light, particularly by the blue frequency light that screens and artificial lighting produce in abundance. The eye sees that light and interprets it as daytime, as mid-morning, as a moment far too early for rest. And so the body waits faithfully for a signal that does not come. This is a very recent problem in evolutionary terms. For most of human history, the blue light of day faded reliably as the sun descended, and the body's ancient timing system had no reason to doubt what it was told. It may be that the body is still waiting most evenings for that older kind of darkness. The one that came slowly, that smelled of cooling earth and wood smoke, that softened gradually into full night without the interruption of screens. There is a quietness that belongs specifically to the biological evening. Researchers studying the patterns of animal behavior at dusk have noted something consistent across species: a period of gradual withdrawal. Birds settle into branches, deer move towards shelter. Even insects, which seem to have no particular relationship with comfort, follow daily rhythms that wind down as the sky darkens. It is as though the whole of the living world participates in the same slow consensus that night is for stillness, and the body ought to honor that. The mind quietly registers this consensus even when the conscious self is not paying attention. Psychologists often note that there are two distinct systems in the human body that govern sleep. One is the circadian signal, the rhythm that ties the body to the day. The other is what scientists call sleep pressure, or the homeostatic drive. This is simply the accumulation of tiredness. The longer the body is awake, the more a particular molecule, adenosine, builds up in the brain. It is a byproduct of neural activity, a chemical residue of thinking and perceiving and moving through the world. As it accumulates, it creates a growing pressure toward rest, a heaviness, a sense that the edges of things are softening. Caffeine, for all its popularity, works by blocking adenosine receptors temporarily, not by reducing the underlying tiredness, but by masking it. The adenosine continues to accumulate regardless, and when the caffeine clears, the pressure returns, sometimes all at once, which is why the afternoon energy drop can feel so sudden, so complete. But tonight, without interference, the adenosine does what it has always done. It builds, it settles, it lends a softness to the world that no amount of willpower could manufacture on its own. It seems that the body has been working toward this moment all day. Every hour of wakefulness was in its own quiet way a preparation for rest. The alertness of morning was simply the body at the far end of a pendulum, and as the hours passed, the pendulum swung, slowly, without resistance, toward here, toward this. Scientists are still exploring the full complexity of what happens in those final hours before sleep, the precise choreography of hormones and temperature, and neural signaling that brings a body to the threshold of rest. But what the evidence keeps suggesting from every direction it is studied is that the process is not fragile. It is robust, deeply practiced. The body has been doing this for a very long time, and it is remarkably good at it when given the chance. It does not need to be told. It does not need to be forced. It needs only to be allowed. and there is something in that which asks very little of the person lying here in the dark, only presence, only a willingness to remain still while the biology does what it was made to do. To trust for a while that the body knows the way that it has always known the way, and that the only thing required right now is to follow it, down into the warmth, into the quiet, into the particular softness that lives just below the surface of waking, and what waits there, what the body has been quietly building toward in every cell through every hour of the day, is something more intricate and more personal than most people realize. Something that does not simply happen to us. Something that in a way that scientists are only beginning to understand we help to make. Part 3. The memory that lives in your cells. Memory is strange. Most people think of it as something that happens in the brain, a filing system, a library of moments stored somewhere behind the eyes retrievable on request, and there is truth in that. The brain does hold memory in the patterns of its connections, in the strength of the pathways between neurons that fired together once and were changed by the experience. But researchers have found over the past few decades that memory is not only a story the brain tells, it is also something the body carries, quietly, in places far from conscious thought, in the architecture of cells that have never read a book or heard a name or recognized a face. The science that describes this is called epigenetics, and it is in the gentlest possible sense one of the most remarkable discoveries of the past century. The word itself means something close to above the gene. Epigenetics is the study of changes in how genes behave, not changes to the genetic code itself, but changes to the way that code is read. Think of it this way. The genome is something like a very long piece of music written out in full. Every note is there, every instruction, every possibility. But epigenetics is the conductor. It determines which passages are played softly, which are held back entirely, which are brought forward and given volume. The same score can sound very different depending on how it is interpreted, and what scientists have discovered is that this interpretation is not fixed at birth. It responds, it shifts, it carries the imprint of experience. Studies indicate that events a person lives through particularly early in life, but not only then, can leave lasting marks on the epigenome. Stress leaves a mark. Sustained calm leaves a different kind of mark. Nutrition, sleep, physical movement, even the quality of relationships a person has, all of these researchers have found, can influence which genes are expressed and which remain quiet. The body listens to the life being lived, and it adjusts accordingly in ways that can persist for years. There is something quietly profound in that. The idea that the body is not simply a carrier of fixed instructions, but a responsive system, a living record of what has been experienced and survived and moved through. But epigenetics goes further than the individual life. This is the part that scientists are still exploring with particular care and attention, because it touches something that was until recently considered impossible. Evidence suggests that some epigenetic changes can be passed from one generation to the next, that what a parent experienced under certain conditions may leave a trace in the biology of their children, not in the genes themselves, but in the way those genes are regulated. Research conducted in the past 2 decades has found echoes of this in animal studies, and more cautiously in certain patterns observed across human populations. The children of people who lived through prolonged periods of scarcity or stress sometimes show physiological differences that correspond in measurable ways to what their parents endured. Differences in stress hormone regulation, in metabolic tendencies, in the sensitivity of the nervous system, as if the body in its quiet wisdom tried to prepare its descendants for a world it recognized. It may be that the body is in some sense always trying to be helpful, always reaching forward, passing along what it has learned. What we understand so far suggests that these inherited patterns are not destiny. They are tendencies, soft leanings. The body offers them not as instructions but as adaptations, starting points shaped by what came before, open to revision by what comes after. Epigenetic marks can change. They respond to new environments, new habits, new experiences of safety and connection. The body is not locked inside its inherited patterns. It can be moved. This is not a small thing. The idea that the biology a person carries is not a sentence but a conversation, one that began long before them and will continue long after, but that is also happening right now tonight in the quiet transactions of a resting body. The brain tends to consolidate its most meaningful experiences during sleep. This much researchers have established with some confidence. The hippocampus, the region most closely associated with the formation of new memories, communicates with the cortex during sleep in a particular rhythm, replaying and reorganizing the events of the day in a way that determines what is kept, what is strengthened, and what is allowed to fade. But what is becoming clearer slowly is that this process of overnight consolidation is not purely about facts and events. It also touches something more physical, more cellular. Neuroscientists have observed that sleep appears to support epigenetic processes as well. The rest that the body enters each night seems to allow for certain kinds of chemical maintenance, attending to the markers on the genome that would not happen so effectively in waking hours. The body uses the quiet to do its most careful editing, to update its record of who it is and what it has been through. Sleep in this way is not just a rest for the mind, it is a rest for the cell. There is something in that which feels almost ceremonial. The nightly return to stillness as a form of maintenance of renewal of the body quietly revising itself. Not erasing what has been the marks remain, but working with them, tending to them, keeping them in a form that the organism can use. Psychologists often note that one of the most consistent findings in the study of resilience, the capacity to recover from difficulty, is that it is not simply a personality trait. It is a biological state. People who sleep consistently and well show measurable differences in their stress response systems, in their inflammatory markers, in the flexibility of their nervous system's reaction to challenge. Resilience, it turns out, is something the body builds, quietly, in the dark, one night at a time. The mind quietly registers all of this even when no conscious record is kept. There is a kind of continuity to the body that extends in both directions a long time. Back through the experiences of a lifetime, back through the biology inherited from those who came before, and forward in the slow changes being made right now in the cells of a body lying still and warm and breathing. Every night is part of this. Every hour of genuine rest is in the cellular sense a small act of maintenance on a very long story. The body is not passive in its stillness. It is busy in its own quiet way, reviewing, adjusting, carrying forward what it has learned. Not loudly, not urgently, with the particular patience of a system that has been doing this for a very long time and that knows the work cannot be rushed. It seems that the most important things the body does, it does in exactly this way, in the absence of noise, in the absence of effort, in the hours when the thinking mind has finally stepped back and left the floor to something older and more reliable. And what scientists have found when they look even deeper into this quiet cellular life below memory, below chemistry, below the language of genes and the marks left upon them, is something that exists at a still more fundamental level. A layer of the body's inner life that most people never consider and that the body never discusses. Something the body has always known and carries without translation. Something changes in the mind when it stops trying. It is not a dramatic change. There is no clear moment when it happens, no switch that flips, no threshold you cross, and know that you have crossed. It is more like the way fog settles gradually, almost imperceptibly, until you notice that the edges of things have become less defined, and the sharpness that carried you through the day has quietly, without ceremony, begun to dissolve. Neuroscientists have observed this softening for decades, and what they have found looking into the brain during its quieter hours is not emptiness, not silence in the way silence is usually imagined. What they find is a different kind of activity, a network that becomes more coherent, more coordinated, more gently alive, precisely when the effort of focused thinking falls away. Scientists call it the default mode network. The name is unassuming, almost accidental. It was originally used to describe what the brain was doing when it was not doing anything in particular. A kind of background hum, like the low idle of an engine at rest. But the more researchers studied it, the more they realized that what looked like idle was not idle at all. It was something else entirely. The default mode network is a constellation of brain regions spread across the inner surface of the cortex, woven through structures deep in the brain's center that become active together during rest, during daydream, during the kind of unfocused awareness that happens when the mind is allowed to wander without destination. Researchers have found that this network is involved in some of the most essentially human things the brain does: the ability to imagine futures that have not happened, to reconstruct the perspectives of other people, to find meaning in experience, to understand a story, including the story of oneself. It seems that the brain's most intimate work happens not when it is focused, but when it is free. There is a particular quality to the thinking that emerges when the default mode network takes over. It is associative rather than linear. It does not move from A to B to C. It drifts from an image to a feeling to a half-remembered conversation to the texture of something experienced years ago. Psychologists often note that this kind of thinking is not less intelligent than focused thought. It is differently intelligent. It makes connections that deliberate reasoning tends to miss. It finds the thread between things that logic would never have thought to place side by side. Some of the most quietly significant moments of understanding in a person's life arrive this way, not through effort, through release. Evidence suggests that the default mode network and the brain's focused attention systems operate in something like opposition. When one becomes more active, the other tends to quiet down. During demanding tasks, reading closely, solving a problem, navigating an unfamiliar place, the attention network holds the stage and the default mode steps back. But as the task ends, as the pressure lifts, the default mode gently re-emerges, like a room that returns to its natural temperature once the heater is switched off. The brain tends to rest not by going blank, but by going home. What this means practically is that the hours of quiet, the time spent not thinking about anything in particular, the long drift of a sleepless night or the soft wandering before sleep takes hold are not wasted. The mind quietly registers what has happened during the day. It draws loose connections. It allows the emotional residue of experience to find somewhere to settle. Researchers studying memory consolidation have found that this unfocused processing plays a genuine role in how the brain decides what to keep and what to release. Not through deliberate review, but through the gentle repetitive replay that happens at the edges of consciousness. The mind sorts itself in the quiet, without being asked, without knowing it is doing it. There is a kind of thinking, too, that happens specifically in the transition between waking and sleep, in that soft corridor of half-awareness, where the body is still, but the mind has not yet fully let go. Scientists studying this hypnagogic state have found that it produces a particular type of associative thought, loose, imagistic, unguarded, that some researchers believe may function as a form of creative processing. The brain, freed from the constraints of logical progression, begins to make unexpected connections, to see things from angles that waking thought would not have permitted. Thomas Edison, The story goes used to fall asleep in a chair holding steel balls in each hand. When sleep took him fully and his grip relaxed, the balls would fall and wake him, and he would immediately write down whatever had been forming in his mind at the moment of release. He understood intuitively what neuroscientists would later confirm, that the thinking which happens at the threshold of sleep is different in quality from waking thought, richer in some ways, more surprising, less edited by the self that usually watches over what the mind produces. It may be that the moments just before sleep are among the most generative the mind ever has, and that we pass through them most nights without knowing what is quietly being made there. Researchers have found that people who rest with an unsolved problem, not actively thinking about it, simply carrying it with them into stillness, often find that something has shifted by the time awareness returns. Not a solution exactly, something subtler than that. A loosening of the way the problem was held, a new angle that had not been visible before. The brain, working in its own time, in its own language, had continued to turn the question over in the dark. What we understand so far suggests that the brain never entirely stops working. Even in the deepest stages of sleep, regions associated with memory and emotion and self-concept remain active. They communicate with each other in patterns that look on a brain scan like ongoing conversation. The conscious self is absent from that conversation, but the conversation continues regardless. The brain, it turns out, trusts itself more than the mind trusts it. There is something worth sitting with in that. The idea that the most essential processing, the work of meaning-making, of emotional integration, of understanding what has happened and where it belongs in the larger shape of a life, does not require conscious participation. That it happens anyway. That the mind has its own way of doing what needs to be done in its own time, by its own quiet methods. All the focused effort of the day was real and necessary. And this, the letting go, the not thinking, the slow drift toward rest, is just as real and just as necessary. Two kinds of work, two kinds of knowing, neither complete without the other. The brain does not need you to stay awake to finish what it has started. It only needs the room to grow still, the light to leave, the long familiar quiet to settle back in the way it has settled every night for as long as there has been a mind to hold it. And somewhere in that settling, in the soft and unmapped territory between thought and sleep, something continues. Something patient and unhurried, working through the hours with a care that the waking self could never quite match. It knows what it is doing. It has always known. And what it tends to find in the deepest layers of that quiet is something that does not belong to any single night, something older, more continuous, woven into the fabric of the body itself, in ways that the conscious mind rarely has reason to notice. Light does not simply illuminate, it informs. It carries instructions, quiet, precise, delivered without words, to nearly every living thing that has ever existed on this planet. And most of those living things have been reading those instructions for so long that the reading has become indistinguishable from breathing, from existing, from simply being alive in the particular way that they are alive. Scientists have known for some time that light governs far more than vision, but the more carefully researchers have looked, the more they have found that the relationship between light and living tissue is something richer, more intricate, and in some ways more intimate than anyone first imagined. It is not simply a matter of brightness or darkness. It is a matter of wavelength, of timing, of the specific quality of light at specific moments in the day, and the way that quality carries information the body has learned over hundreds of millions of years to trust. The story begins, in a sense, with a single-celled organism floating in ancient water. Long before there were eyes, long before there were brains or nervous systems or any of the complex biological machinery that allows a creature to perceive and respond to its world, there were cells that could detect light, not see it exactly, not form an image of it, but sense it, register its presence or absence and adjust their behavior accordingly. Researchers have found photoreceptive proteins in organisms so ancient and so simple that they predate the development of multicellular life itself. The ability to read light is, in biological terms, one of the oldest skills in existence. Everything that came afterward, every eye that ever opened, every rhythm that ever tuned itself to the turning of the earth, built on that original unhurried discovery. In plants, the relationship with light became something extraordinary. Neuroscientists observe that in animals, but botanists studying plant physiology have found that plants possess what might be called a distributed sensory system. No brain, no central processor, but thousands of photoreceptive proteins spread across every leaf and stem, each one responding to a different quality of light. Some detect blue wavelengths and use that information to orient leaves toward the sun. Others detect the ratio of red to far red light, a ratio that changes depending on whether the plant is growing in open sunlight or in the shade of other plants, and use that information to decide whether to grow tall and reach outward or to focus energy elsewhere. A plant standing in a forest is reading the light around it the way a careful reader reads a page, slowly, with attention to detail, extracting meaning from what might look to a casual observer like simple brightness. Evidence suggests that even the timing of flowering in many plant species is governed not by temperature alone, as was once assumed, but by day length, by the precise duration of light and darkness across a 24-hour period. The plant measures this duration with a chemical precision that would be remarkable in any instrument. It knows without being told whether the season is advancing or retreating, whether the long days of summer are lengthening or beginning their slow return toward winter. And it adjusts its biology accordingly, blooming, setting seed, withdrawing, in a rhythm that has been calibrated over millions of years of practice. There is a patience in that which is difficult to fully appreciate, a kind of deep, unhurried intelligence that operates entirely without urgency. In animals, the language of light became more elaborate still. Researchers studying marine organisms have found that some species of deep-sea creatures, living in water so dark that no sunlight penetrates at all, still maintain internal rhythms that echo the cycles of day and night on the surface above them. Not because they can see the light, but because their ancestors once could, and the rhythm was encoded so deeply into their biology that even the absence of the signal could not entirely erase it. The clock runs on in the dark by memory. It may be that this is one of the most quietly astonishing things in all of biology, that the relationship between living things and light runs so deep that it persists even where light itself is absent, that the body carries the rhythm of the sun in a place the sun can no longer reach. Researchers have found something similar in human beings kept in environments without any natural light cues. Volunteers in underground bunkers or in rooms with no windows and no clocks still maintain rhythms close to 24 hours. Their body temperature still rises and falls on a daily cycle. Their hormone levels still shift in patterns that echo faintly but unmistakably the pattern of a normal day and night. The rhythm persists without the signal, the way a song continues in the mind long after the music has stopped. What we understand so far suggests that this internal timekeeping is maintained by a cluster of neurons in the brain, a region called the suprachiasmatic nucleus, sitting just above the point where the optic nerves cross-positioned as though by design to receive light information directly from the eyes. This cluster of roughly 20,000 cells acts as the brain's master clock, synchronizing the timing systems spread throughout the rest of the body. And it is extraordinarily precise. Under normal conditions, receiving regular light cues, it maintains rhythms accurate to within minutes over the course of days. 20,000 cells coordinating the timing of an entire organism reading the sky. The quality of evening light does something specific to this system that morning light does not. As the sky shifts from the blue heavy spectrum of midday toward the warmer redder tones of late afternoon and dusk, the suprachiasmatic nucleus interprets that shift as a signal that the day is winding toward its end. It begins to adjust, to prepare. The brain tends to respond to that warm amber light with a gradual softening of alertness, not a crash, not a sudden heaviness, but a gentle decline like a tide pulling back from shore. Scientists suggest this is why candlelight and firelight have always felt calming to human beings, not only because they are culturally associated with rest, but because their spectral quality warm-low in blue, flickering gently mimics the light of a world moving toward night. The body reads it as evening, as permission, as the beginning of the long release. There is something in the eye discovered only in the early years of this century that most people have never heard of. A third type of photoreceptor, distinct from the rods and cones used for ordinary vision, that exists specifically to serve the body's timekeeping system. These cells do not contribute to the images the brain constructs of the world. They are not involved in color perception or motion detection. Their only function is to measure the ambient light level and report it steadily and reliably to the master clock. They are not eyes in any ordinary sense, they are clocks, living light-sensitive clocks embedded in the tissue of the retina doing nothing but keeping time. It may be that the eye was always more than a window, that it was from the very beginning also a compass, a calendar, an instrument for navigating time as much as space. The mind quietly registers all of this without knowing it does. The warm light of a lamp, the gradual dimming of the room, the particular softness of a night that has fully arrived. Each signal is received and processed by systems so old, so automatic, so deeply woven into the body's fabric that they require no conscious involvement whatsoever. The body reads the light, it always has, and in the reading something loosens. Something that has been held alert and attentive through the hours of the day begins at last to let go the way a hand that has been holding something carefully for a long time finally opens, not because it was told to, but because the holding is simply no longer needed. Darkness is not absence, it is arrival, and what arrives with it, what the body has been quietly waiting for through every hour of the light, is something that lives not in the eyes, not in the clock, not in any single system or signal or cell, but in the accumulated quiet of a body that has read the world carefully all day and is now at last ready to set the reading down. What happens next is something the body does not need light to find its way through. It knows the path by feel, by the particular texture of this stillness which is different from all other stillnesses, and which the deepest parts of the biology recognize the way the body recognizes home. There is a place the mind goes sometimes without being directed, not sleep, not waking, not quite either. A corridor between the two narrow, unhurried, lit by something that has no obvious source. You've been there before many times, you may be approaching it now. It is the place where a thought begins, and then before it can fully form becomes something else, where the logic of the day grows permeable, where the ordinary rules of sequence and consequence quietly suspend themselves, and the mind moves if moved is even the right word through something more like atmosphere than thought. Scientists have only recently begun to study this space with any real precision, and what they are finding there is not nothing. It is not the absence of mental activity. It is in certain measurable ways a remarkable abundance of it, organized differently, governed by different principles, operating in a register. The waking mind rarely enters, and the sleeping mind has already left behind. The space between thoughts, it turns out, is one of the most active places in the brain. Neuroscientists have observed that neural communication does not happen in a continuous stream. It happens in pulses, Neurons fire and then they rest. They fire again and rest again. And in the intervals, those tiny gaps between one moment of activation and the next, the brain is not simply waiting. Researchers have found that these resting intervals are when a great deal of the brain's coordination happens, when different regions synchronize their timing, when the slow oscillations that organize large-scale brain activity, the rhythms that researchers measure in waves, in frequencies, in the particular cadences of a brain, moving through its various states, find their coherence. The pause is not empty. The pause is where the orchestra tunes. There is a frequency the brain produces during relaxed eyes-closed wakefulness, a gentle rhythm that neuroscientists call alpha waves, oscillating at roughly 8 to 12 cycles per second. This frequency tends to appear when the mind is calm but still present, when attention has loosened its grip on any particular object and allowed itself to become ambient. Researchers have found that alpha activity increases in the visual cortex when the eyes are closed, even in complete darkness, as if the brain freed from the work of processing. The visual world begins to generate its own quiet signal, its own internal hum. It seems that the resting brain is not simply less active than the working brain. It is differently active, turning its attention inward toward its own rhythms, its own communication, its own soft and continuous inner life. There is a related rhythm, slower, deeper, that begins to emerge as the brain approaches the threshold of sleep. Theta waves researchers call them oscillating at 4 to 8 cycles per second. They are associated with the hypnagogic state that Twilight Corridor mentioned earlier, and also with certain kinds of deep meditation, and with the particular quality of thought that arises during long quiet walks, or during the unfocused reverie of a mind allowed to drift without destination. Psychologists often note that theta activity is associated with heightened access to memories and images that are not usually available to waking consciousness, as though the slower rhythm loosens something that the faster rhythms of alert thought keep carefully in place. What becomes accessible in theta researchers suggest is a layer of the mind that is always present but rarely audible above the noise of ordinary thinking. The mind quietly registers this shift, usually without naming it. There is change in the quality of attention, a loosening, a softening, a sense that the boundaries between self and surrounding have grown slightly less defined. Thoughts arrive without being summoned. They leave without being dismissed. The inner voice, if it speaks at all, speaks more slowly, with longer pauses, with less urgency about being heard. This is not a failure of the mind. It is the mind doing something it was made to do. Evidence suggests that the transition from alpha to theta, from relaxed wakefulness to the edge of sleep, is accompanied by a measurable change in the body as well. Muscle tone decreases. The jaw softens. The small muscles around the eyes relax in a way that is difficult to replicate deliberately. The breath becomes slower and more irregular, not the steady rhythm of alert breathing, but something more variable, more organic, shaped by the body's own quiet tidal movement, rather than by any conscious intention. The body and the brain in these moments are in the process of becoming the same thing. The boundary between mental state and physical state dissolves at the edges. What the brain does, the body reflects. What the body releases, the brain follows. Scientists are still exploring exactly what determines how quickly and how fully this transition occurs. There are differences between individuals. Some people move through the corridor quickly, others linger in it for long periods, and neither is wrong. The architecture of the transition varies, but what researchers keep finding across all the variation is that the process is not something that can be forced. Attention directed at the transition tends to interrupt it. The mind, noticing itself approaching sleep, often retreats from the approach. It may be that the only reliable path through the corridor is the one taken without looking. There is a kind of knowledge that works this way. Not the knowledge of facts or skills, but the knowledge of how to allow something, how to stay present without gripping, how to remain aware without demanding that awareness produce anything. Researchers studying experienced meditators have found that long practice with this kind of allowing tends to shorten the transition to sleep, to smooth the passage through its stages, to deepen the quality of rest that follows. Not because meditation teaches the brain to sleep, but because it teaches the self to stop interrupting the brain's own very capable process. The brain knows how to sleep. It has always known. What it sometimes needs is simply for the rest of the person to become quiet enough for that knowing to proceed. There are cultures, and there have been moments in history where this corridor was treated not as a transition to be passed through as quickly as possible, but as a destination in itself, a place worth visiting, worth lingering in. The hypnagogic state was known to artists and scientists and thinkers across many centuries, often described in terms that sound less like neuroscience, and more like something encountered rather than produced. A place where images arrive unbidden, where connections form that logic would never have authorized, where the mind, relieved of its usual obligations, becomes briefly capable of something that resembles more than anything else genuine surprise at its own contents. Scientists are still exploring what exactly is happening in this state at the level of individual neurons and neural circuits. But what the research keeps suggesting from the outside is something worth knowing, that what most people pass through every night, barely noticing on their way to sleep, that soft dissolving corridor of half-formed images and loosening thought, is one of the most unusual, and perhaps one of the most generative states the human brain ever enters. And it is available every night without instruction, without effort, without cost. It requires only that the room be quiet, and that the thinking for a while be allowed to go wherever it goes. The breath slows, the rhythm deepens, the boundary between the thought and the thinker grows for a moment difficult to locate. And somewhere in that difficulty, somewhere in the gentle confusion of where the mind ends and something else begins, there is a layer that most people move through so quickly they never quite feel it. A place where the brain is doing something with the day that the day itself never had time to allow, sorting, settling, finding the shape of things that looked shapeless in the light. There is a quieter layer beneath even this one that scientists have only recently found the instruments to see. Something that happens not at the surface of sleep, but in its depths, in the slow and rhythmic dark of its longest hours. Something the body has been preparing for without announcement since the moment the day began. No one chooses what they dream. That is perhaps the most remarkable thing about it. For all the control the waking mind exercises over the shape of a day, what to attend to, what to pursue, what to set aside, the dreaming mind answers to none of that. It moves by its own rules, follows its own logic, populates its own landscapes with faces and weather and impossible architectures that dissolve the moment they are looked at too directly. And yet it is not random, not truly. The more carefully researchers have studied the dreaming brain, the more they have found that what looks like chaos from the outside has a kind of order to it, a purpose, an elegant, unhurried purpose that the waking mind could never have designed. Dreaming, it turns out, is one of the most sophisticated things the brain does. The sleep that carries dreams the stage researchers call rapid eye movement sleep, or the phase in which the eyes move behind closed lids in quick irregular bursts, accounts for roughly a quarter of a full night's rest in healthy adults. It tends to arrive later in the night in longer and longer episodes as the hours accumulate. The first dream of the night may last only a few minutes. The last in the early hours before waking may stretch across 20 minutes or more, as though the dreaming mind, like a musician warming up, finds its full range only gradually. Neuroscientists have observed that the brain during rapid eye movement sleep is in certain measurable ways more active than during waking. Not in every region equally, but in those associated with emotion, with memory, with the construction of social and narrative, understanding the activity during dreaming rivals, or exceeds anything seen during the most engaged hours of the day. The prefrontal cortex, the region most associated with rational oversight, with the editing of thought, with the management of impulse and the application of logic, grows quieter, and into the space that its quieting creates something else moves, something less supervised, something older. Evidence suggests that dreaming serves functions that waking cognition simply cannot replicate. Researchers studying the role of rapid eye movement sleep in emotional memory have found something that has taken a long time to fully appreciate. During this phase, the brain replays emotional experiences from the day, not precisely, not like a recording, but in an altered chemical environment. The neurochemical norepinephrine, which is associated with stress and with the emotional charge attached to memory, is almost entirely absent during rapid eye movement sleep. This means the brain can revisit difficult or emotionally significant experiences without the physiological arousal those experiences originally produced. The memory returns, the feeling to some degree does not. What we understand so far suggests that this is not incidental. It may be the point. The brain working through the material of the day and the particular chemistry of the dream state appears to be doing something that resembles, in biological terms, a kind of emotional processing, a quiet nightly recalibration of how experience is held, not erasing what happened, but adjusting the weight of it, softening the edges, filing it in a place where it can be remembered without being relived with the same intensity. Psychologists often note that people who are prevented from dreaming through sleep disruption or chemical interference tend to find that difficult emotions are harder to regulate, that recent experiences feel more vivid and more charged than usual, that the ordinary frictions of daily life accumulate in ways they normally would not, as though something is being left undone, as though the nightly work of the dreaming mind is quietly essential to the emotional balance of the waking one. Sleep, researchers have found, is not just rest, it is maintenance. The content of dreams has fascinated human beings for as long as there have been human beings curious enough to write things down. Ancient Egyptians built temples specifically for dream incubation places where a person might sleep in the hope of receiving guidance through the images of the night. The Greeks maintained similar practices. Many indigenous traditions around the world developed complex frameworks for interpreting and honoring the dream state, treating its images not as noise but as information. Information of a particular kind arriving through a channel that ordinary consciousness could not access. Researchers studying the content of dreams across cultures have found certain patterns that appear with remarkable consistency. Themes of being pursued, of falling, of finding oneself in a place that is familiar but somehow wrong, of trying to speak and finding no sound comes. These images appear across geographic and cultural boundaries in ways that suggest they may reflect something about the dreaming brain itself, about the kinds of emotional and narrative material that the brain naturally returns to when given freedom to choose its own subject. The dreaming mind, it seems, has its own concerns, and they are not always the same as the waking mind's. Scientists are still exploring what determines which memories are selected for processing during dream sleep, and which are simply allowed to fade. But what the research keeps returning to is a picture of the dreaming brain as a curator, not archiving everything indiscriminately, but making choices, prioritizing the emotionally significant, connecting the recent with the older, finding the structural similarities between a thing that happened today and a thing that happened years ago, and placing them gently beside each other the way a librarian might shelve two books on the same subject in the same quiet row. The brain tends to see patterns across time that the conscious mind, focused as it is on the immediate present, tends to miss. There is something in dreaming that resembles creativity in its purest form, not the disciplined application of skill to a problem, but the free movement of the mind through its own material, making connections that no deliberate process would have authorized. Researchers studying the relationship between dream sleep and creative problem solving have found that people who sleep between learning a task and applying it often perform better than those who simply practice without sleep. Not because sleep provides additional time, but because something in the sleeping brain reorganizes the material, finds the underlying structure, simplifies what was complicated. The solution in some sense was always there. The dream made room for it to be seen. It may be that this is why certain ideas arrive in the morning with a clarity they did not have the night before. Not because anything has changed in the external world, but because something has been reorganized in the internal one. The dreaming brain worked through the night on a problem the waking mind had set down without solving, and returned it quietly, slightly transformed. There is a gentleness to this that is easy to overlook. The brain does not announce its nighttime labor. It does not produce a report or a summary or any account of what it worked through or how. It simply returns the world each morning slightly differently arranged, slightly more navigable, slightly more at peace with itself if the night has gone well. Researchers have found that the amount of rapid eye movement sleep a person gets tends to increase during periods of significant learning, emotional challenge, or major life change, as though the dreaming brain senses when more work is needed and quietly expands to meet it. There is something in that which feels almost attentive, almost caring, the body allocating its own resources in the dark and without consultation toward what the person most needs to process. The dreaming mind has its own priorities, and they tend, researchers suggest, to align rather closely with the heart's. What the eyes see behind closed lids, the half-lit rooms, the shifting faces, the landscapes that expand and contract without physical explanation, is not the dream itself. It is only the visible surface of something happening much deeper, in the chemical exchanges between neurons, in the slow oscillations of a brain moving through its most private and most productive hours, in the intricate, invisible work of a mind that has learned over a very long time how to make sense of being alive. And it does this work not through effort, not through discipline, not through any quality of character or will or intention. It does it through surrender, through the particular courage, if courage is the right word, of a mind that can hold the day's experiences without grasping at them, that can let them drift and change and settle into new arrangements that the waking self could never have deliberately chosen. The dreaming mind asks only for darkness and time and the willingness to stop directing. And in the hours that follow, the hours still ahead for anyone lying here still in the quiet, the body offers all three. Something in what the sleeping brain carries through the night runs even deeper than the dream itself. Older, more continuous, laid down in rhythms the body learned long before language gave us words for any of it. The blood is salty. Not in the way that food is salty, not in any way that could be tasted or noticed in the course of a normal day, but chemically, precisely, measurably salty, carrying dissolved minerals in concentrations that bear a quiet resemblance to the ocean. Sodium, potassium, calcium, magnesium. The same elements that drift through seawater, the same balance of charged particles that has sustained marine life for hundreds of millions of years, circulating right now through every vessel in the body that is lying here still and warm in the dark. Researchers have noted this resemblance for a long time. And while the comparison is not perfect, blood is not seawater, and the concentrations differ in ways that matter enormously to biology. The underlying parallel is real enough to have occupied the thinking of scientists for more than a century. The question it raises is not merely chemical, it is historical. It is the quiet suggestion that the body has not entirely left the ocean behind, that something of that first environment, the warm, mineral-rich water where life first learned to sustain itself, was carried inland, enclosed within skin maintained across every evolutionary transition that followed. The body, in a sense, brought the sea with it. What we understand so far suggests that the earliest ancestors of all vertebrate life, the first creatures with backbones and internal skeletons, the distant forebears of everything from fish to birds to the person resting here tonight, evolved entirely within water. For hundreds of millions of years, the chemistry of the surrounding ocean was also the chemistry of the interior. There was no boundary to maintain. The inside and the outside were in the most fundamental chemical sense continuous. When the first creatures began to move onto land, they faced a problem that had no precedent. The ocean, which had always regulated their internal chemistry passively, was no longer available. Everything that the water had provided, the balance of minerals, the medium for cellular communication, the buffering of temperature, now had to be managed from within. The body had to become its own ocean, self-contained, self-regulating, carrying its chemical history inside itself, sealed against a drier world. It seems that this transition, enormous as it was, did not require the body to reinvent itself entirely. It required it to internalize what it had always depended on, to enclose the chemistry that had always surrounded it, and to learn to maintain that chemistry independently through systems of extraordinary precision and patience. The kidneys are perhaps the most eloquent expression of this. Researchers studying kidney function often describe it in terms that sound less like organ physiology and more like environmental management. The kidneys filter the blood continuously, roughly 50 gallons passing through them every day, in a healthy adult removing waste products, while carefully preserving the mineral balance that the cells depend on. They adjust this balance in response to dozens of variables, simultaneously: hydration, blood pressure, the composition of recent meals, the demands of physical activity, the chemical signals of stress or rest. They do all of this without any conscious input, without any awareness from the person whose life they are sustaining. The kidneys, it may be said, are maintaining the ocean. Quietly, continuously, through every hour of every day and night, they are holding the body's internal sea at precisely the salinity and mineral balance that the cells require to function. They have been doing this since long before the body had a brain sophisticated enough to appreciate what they were doing. They will continue doing it through the night ahead, through the slow and restoring hours of sleep, with the same unhurried diligence they bring to every other moment. The body's always working, even now, even in the stillness. There is a particular mineral the body depends on that has a quality worth dwelling on for a moment. Magnesium is involved in more than 300 biochemical reactions in the human body, researchers have found. It participates in the synthesis of proteins, in the regulation of muscle and nerve function, in the control of blood pressure, in the transport of other minerals across cell membranes. It is in a sense one of the body's most indispensable collaborators. And it is also, quietly without fanfare, one of the minerals associated with the capacity for rest. Evidence suggests that magnesium plays a role in regulating the nervous system's transition from alertness to calm. It binds to receptors in the brain that promote relaxation and helps to regulate the neurotransmitters that quiet neural activity in preparation for sleep. Researchers have found that lower magnesium levels are associated with lighter, more fragmented sleep, while adequate levels appear to support the deeper, more restorative stages. The ocean chemistry inside the body, maintained in careful balance by systems that have been refining their methods for hundreds of millions of years, turns out to include the very minerals most conducive to rest. The body was designed in the deepest evolutionary sense to be here, in the dark, growing still. Neuroscientists have observed that the autonomic nervous system, the branch of the nervous system responsible for regulating the body's internal environment without conscious involvement, operates in two broad modes. One is associated with alertness and action, heart rate elevated, digestion, slowed senses, sharpened energy directed outward toward the demands of the world. The other is associated with rest and restoration, heart rate lowered, digestion. Resumed the immune system given resources to do its quiet repair work, energy turned inward toward the maintenance of the body itself. Scientists often refer to these modes as activation and restoration. The body moves between them continuously, but the balance shifts depending on circumstance. And what researchers keep finding is that the restoration mode, the state, the nervous system enters most fully during sleep, is not merely the absence of the other. It is a state of active, purposeful biological work. The immune system becomes more active during sleep, producing and deploying the cells and proteins involved in identifying and responding to threats. Tissue repair accelerates. Hormones that support cellular maintenance and growth are released in their highest concentrations during the deepest stages of sleep. The body is at its most industrious when it appears from the outside to be doing nothing at all. There is a particular protein the body produces during sleep that researchers have only recently begun to study in detail. It belongs to a class of molecules involved in cellular cleanup, the identification and removal of damaged or misfolded proteins that accumulate in tissue over the course of a day's activity. The brain, which is metabolically one of the most active organs in the body, produces more of this cellular debris than most other tissues, and it clears it most efficiently during sleep through the glymphatic system described earlier in the night, that slow rhythmic flushing of cerebrospinal fluid that expands into the spaces between neurons as the brain rests, and the neurons themselves shrink slightly in size. The brain makes room for the cleaning to happen. It literally changes its own architecture slightly to allow the fluid to move more freely through it. This is not a passive process. It is not simply what happens when activity decreases. It is a coordinated, active physiological event that requires the right conditions, the right depth of sleep, the right duration of rest. It may be that the brain's most essential work of self-maintenance can only happen when the self is no longer watching. Psychologists often note that human beings tend to underestimate the physical dimension of rest. Sleep is understood culturally as something the mind needs, a cognitive necessity, a mental recharge, and it is those things. But the body's need for sleep is at least as ancient as the brain's, and in some respects more fundamental. Every major organ system is affected by sleep duration and quality. The heart, the immune system, the digestive system, the endocrine system, which governs the release of the hormones that regulate everything from metabolism to mood to the stress response. The body is not simply waiting during sleep for the brain to finish its processing. It is conducting its own extensive, sophisticated program of maintenance and renewal. Sleep is when the body remembers how to be itself. The minerals in the blood continue their slow circulation. The kidneys continue their patient work. The immune cells move through their surveillance routes, checking the tissues, maintaining the integrity of systems that the conscious mind will never directly perceive. The heart beats on 60 or 70 times per minute, adjusted downward from the pace of the day by the same nervous system that will in the hours ahead slowly guide the body into its deepest rest. And somewhere in the middle of all this quiet industry, somewhere between the chemistry of the ocean that the body carries within it and the ancient rhythms that have governed rest, for longer than there have been human beings to experience it, there is a stillness that does not belong to any single system or organ or biological process, a stillness that is simply the sum of all of them at rest at once, moving gently, working softly, sustaining the life that lies here in the dark without being asked, without needing acknowledgement, without requiring anything from the person they belong to, except the willingness to remain still. The body knows what it is doing, it has always known, and in the hours just ahead as the deeper stages of sleep begin to arrive, something even more continuous begins to make itself felt, a rhythm so old it predates the body itself, something the living world did not invent but learned very gradually to follow. The earth hums, not loudly, not in any way that ordinary hearing can detect without instruments, but it hums a continuous low-frequency electromagnetic resonance generated in the cavity between the surface of the planet and the lower boundary of the ionosphere, that thin shell of electrically charged particles that surrounds the Earth roughly 60 miles above the ground. Lightning strikes the Earth approximately 100 times every second somewhere on the planet at every moment of every day. Each strike sends electromagnetic energy radiating outward, and that energy travels around the world, bouncing between the surface and the ionosphere, reinforcing itself where the waves meet and overlap. The result is a set of resonant frequencies, the lowest hovering near 7.8 cycles per second, that circle the Earth continuously like a standing wave in a vast planetary instrument. Scientists call them Schumann resonances, after the physicist Winfried Otto Schumann, who predicted their existence mathematically in the early 1950s, before instruments sensitive enough to confirm them had even been built. When the measurements finally came, they matched the prediction with a precision that still feels, in retrospect, quietly astonishing. The Earth had been generating these frequencies all along, through every century of human existence, through every night that anyone had ever lain down to rest beneath an open sky. The hum had always been there. Only the mathematics arrived late. What makes this more than a curiosity of atmospheric physics is what researchers began to notice when they compared the Schumann frequencies to the electrical activity of the human brain. The lowest Schumann resonance, that fundamental frequency near 7.8 cycles per second, falls within the range of theta waves, the brain rhythms associated with the edges of sleep and deep meditative states. The second harmonic near 14 cycles per second overlaps with the lower range of beta waves associated with relaxed wakefulness. The third near 20 cycles per second sits within the range of higher beta activity. Scientists are still exploring whether this overlap is coincidental or whether it reflects something deeper, some long evolutionary relationship between the rhythms of the living brain and the electromagnetic environment in which all terrestrial life has always existed. The evidence so far is suggestive rather than conclusive, but what it suggests is worth sitting with for a moment in the quiet. It may be that the brain did not develop its rhythms in isolation, that the electromagnetic environment of the Earth, constant, ancient, present at every moment of evolutionary history, formed part of the background against which the nervous system calibrated itself. Not a cause, perhaps, but a context, a frame within which the frequencies of thought and rest found their natural range. Researchers studying the effects of Schumann resonances on biological systems have found correlations, careful, measured, not yet fully understood, between fluctuations in the Earth's electromagnetic field and changes in human physiological rhythms, heart rate variability, melatonin levels, the timing of sleep onset. The body, it seems, may be listening to the planet, not consciously, not in any way that the mind can feel or direct, but in the deep automatic way that living systems have always responded to the environment that shaped them, through the accumulated sensitivity of hundreds of millions of years of existence within the same electromagnetic field. The Earth breathes and the body perhaps breathes with it. There is something in this that asks very little of the intellect and a great deal of something quieter. The idea that the planet itself is not merely a surface to live on, but an environment that the body is in continuous relationship with. That the ground underfoot and the ionosphere overhead form a kind of living system resonant and active, and that the human nervous system exists within that system not as a visitor, but as a participant. Something attuned over a very long time to frequencies it has never needed to consciously perceive. Researchers studying the physiology of people who spend extended time in nature, away from the electromagnetic noise of cities, away from the dense overlay of human-generated frequencies, have found measurable changes in stress markers in sleep quality, in the coherence of heart rate variability. Whether these changes are attributable specifically to Schumann resonances or to the broader sensory environment of natural settings remains an open question. Scientists are still exploring where one influence ends and another begins, but the pattern is consistent enough to suggest that the body responds differently to natural electromagnetic environments than to artificial ones. That something in the nervous system recognizes a difference it has never been taught to recognize. The body knows the difference between a natural night and an artificial one. It always has. There is a related phenomenon less well known and even more difficult to explain that researchers in the field of chronobiology have been quietly investigating for several decades. The human body they have found is not governed by a single biological clock. It is governed by many, hundreds of them distributed across tissues and organs, each maintaining its own rhythmic cycling. The master clock in the brain coordinates them as described earlier in the night, but the peripheral clocks are not merely passive receivers of that coordination. They have their own timekeeping capacity, their own internal rhythmicity maintained even when the master clock's signal is absent. What we understand so far suggests that these peripheral clocks can be influenced by stimuli that the master clock does not directly receive. The clock in the liver responds to the timing of meals. The clock in muscle tissue responds to the timing of physical activity. The clock in the skin responds to some degree to local light exposure. Each tissue, in a sense, is keeping its own time, consulting the master clock for coordination, but maintaining its own independent relationship with the rhythms of the world. The body is not a single timekeeper. It is a choir. Each voice with its own timing, its own particular relationship with the beat, held together by the quietest conductor imaginable, a few thousand neurons tucked just behind the eyes, reading the light of day with a sensitivity that has never required any attention from the person it serves. Neuroscientists have observed that the coherence of these distributed clocks, how well they are synchronized with each other and with the master rhythm, is associated with overall health in ways that are still being mapped. When the peripheral clocks fall out of alignment through shift work, through irregular schedules, through the disruption of a normal light exposure and meal timing, the body begins to show strain in ways that are measurable, but not always immediately obvious. Digestion becomes less efficient. Immune function fluctuates in unpredictable ways. The emotional regulation that normally proceeds without effort becomes slightly more difficult. Small frictions accumulate. The body researchers suggest functions best as a coherent system. When all the rhythms are in conversation with each other, when the liver's clock and the brain's clock and the heart's clock are all following the same broad arc through the day, something settles. Something that is difficult to name but easy to notice in its absence as a kind of ease, a sense that the parts are working together, that the body is not managing multiple competing agendas but moving as a whole in a single quiet direction. That direction right now is toward rest, and the rhythms that govern it, the ancient electromagnetic hum of the planet, the circadian choreography of the body's distributed clocks, the slow descent of temperature and hormone and neural activity that carries every living creature toward the repair and renewal of sleep, are not things that need to be understood to be felt. They do not require comprehension. They do not require cooperation in any deliberate sense. They require only the absence of resistance, the willingness to become for a while part of the rhythm rather than apart from it. The earth hums at its own frequency as it has through every night of human history. The body hums along in its own quiet register as it was always inclined to do. And the space between the two, between the planet and the person, is not the distance it might seem. It is perhaps no distance at all. The mind, it seems, has been keeping something still and patient all along, something older than thought, older than memory, woven into the very frequency at which the body moves through its own quiet hours. And what that something has been holding through all the noise and light of the day just past is a quality of rest so complete, so unhurried that it exists less like a destination and more like a place the body never entirely left. There is light arriving tonight that left its source before the earth existed, not metaphorically, not as a way of speaking about time, literally photons that have been travelling through the void of space for longer than the solar system has been here, crossing distances that have no adequate human reference point, and arriving now tonight at the surface of an eye that will never know they came. They pass through the atmosphere without ceremony. They land on the retina. They are registered or they are not, and either way they continue because light once released does not stop simply because it has reached something. The sky above this room is full of arrivals, constant, silent, unannounced. Researchers have found that the light reaching the Earth from distant stars is not a live transmission. It is in the most literal sense the past. The star that produced it may no longer exist. It may have changed beyond recognition, expanded, cooled, collapsed into something dense and dark that no ordinary light can escape. What the eye sees looking upward on a clear night is not the current state of the universe. It is a layered record of many different moments, each one arriving from a different distance, each one therefore from a different point in time, all of them reaching the eye simultaneously composited into a single image that feels like the present, but is in fact a kind of deep archive. The night sky is not a window, it is a history. Scientists call this phenomenon look-back time. The concept is straightforward, but its implications take a moment to settle into. The farther away an object is, the longer its light takes to reach us, and therefore the further back in time we are seeing it. The moon, as it appears tonight, is the moon as it was roughly 1¼ seconds ago, close enough to be effectively present. The sun is 8 minutes in the past. The nearest star beyond the sun sits about 4 light years away, meaning the light arriving from it tonight left its surface 4 years ago. The stars that form the familiar constellations, the patterns human beings have been watching and naming for thousands of years, are mostly between a few dozen and a few hundred light years distant. Ancient light by any human measure, but young by the standards of the cosmos. The most distant objects visible to the unaided eye are galaxies, collections of hundreds of billions of stars so remote that their light has been travelling for millions of years. The Andromeda galaxy, faintly visible on a dark night as a soft blur near the constellation, Perseus, is roughly 2.5 million light-years away. The light arriving from it tonight left its source before the genus Homo existed, before the first stone tools, before anything that could be called human had yet walked on the earth, and yet it arrives, patient, unchanged, carrying information across a span of time that the mind can state but cannot truly hold. Evidence suggests that the human brain is not well equipped to intuitively grasp cosmic distances or timescales. This is not a failure of intelligence, It is simply that the scales involved have no relationship to anything in ordinary human experience. The brain tends to process very large numbers by abstracting them, stripping them of their texture, converting them into symbols that can be manipulated without being felt. 1,000,000 years and 1,000,000,000 years feel to most people roughly similar, both simply very long. The difference between them, which is 999 million years, tends to dissolve. But there is another way to approach these distances, not through the numbers, but through the image they produce. The star seen tonight is not a point of light. It is a message, something that existed at some point in a particular state, and sent this small packet of information outward into the universe with no particular destination, with no expectation of arrival, and it has been travelling ever since, through the expansion of space itself, through the slow cooling of the cosmos, through every era of geological and biological history on this planet, and it arrives here, now. On a night when a person is lying still, and the room is quiet, and the only thing required is to be present for a moment that has been travelling in some sense for longer than life on Earth has existed. There is a quality to that which is difficult to name, not awe exactly, something quieter than awe. A sense of proportion, perhaps. A gentle reminder of the scale within which the small and precious details of a human life are embedded. Neuroscientists have observed that exposure to experiences of vast scale, standing at the edge of a canyon, looking out over open ocean, contemplating the age of a mountain range, tends to produce a specific emotional response that researchers have studied under the name of awe. But awe in its softer forms does not require a dramatic encounter with scale. It may be that the mind quietly registers something similar in more subtle encounters, the thought held gently in the dark that the light coming through the window has travelled further than imagination can follow, that the ground beneath this building contains minerals older than the sun, that the carbon in every cell of the body was forged in the core of a star that no longer exists. These are not frightening thoughts. They are grounding ones. Grounding in the largest possible sense, connecting the small fact of a single night, a single body at rest, to something continuous and ancient that does not require any acknowledgement to continue. It may be that this is one of the quieter gifts of knowing something about the universe, not the drama of its scale, but the comfort of belonging to it, the understanding that the atoms in this body have been part of the universe for as long as the universe has existed, that they were present at the formation of stars, that they have been part of ocean floors and mountain ranges, and the bodies of creatures so different from anything alive today that no adequate image exists for them, and that they are here now organized into this particular arrangement, warm and resting, moving gently with each breath. The atoms do not know they are resting, but they are. And they have been many things before this, and they will be many things after, and right now they are precisely here. Researchers studying what is sometimes called the overview effect, the cognitive and emotional shift reported by astronauts who have seen the Earth from space, have found that the experience of perceiving the planet as a small, fragile object suspended in an enormous darkness tends to produce lasting changes in perspective. A reduced preoccupation with ordinary concerns, an increased sense of connection to other people and to the living systems of the Earth. A quiet but persistent feeling that the boundaries between self and world are less absolute than they seemed. What we understand so far suggests that this shift does not require spaceflight to occur, at least in milder forms. Contemplating the night sky, genuinely contemplating it, allowing the mind to follow the implications of what is being seen, can produce something of the same loosening. The self encountered in the context of a universe 14 billion years old and 46 billion light-years across becomes slightly less insistent on its own urgency. its concerns, real and valid as they are, settle into a broader frame. The things that seemed pressing soften just a little in the presence of all that distance. The mind quietly registers the scale of what it belongs to, and something in the registering brings relief. Scientists are still exploring the neural mechanisms behind this response, what happens in the brain when scale is genuinely apprehended rather than merely noted. But the phenomenology is consistent enough to be trusted. The encounter with vastness, when it is allowed to be felt rather than simply processed, tends to quiet the noise of the immediate, to create a momentary pause in the continuous narration of the self, to allow something that was tightly held to loosen at least briefly in the recognition that the holding was never quite as necessary as it felt. The light from Andromeda has been travelling for 2.5 million years. It does not require anything from the person it reaches. It does not ask to be understood or interpreted or remembered. It arrives and it passes through, and the universe continues its own long, unhurried unfolding, indifferent to urgency, unmoved by deadline organised around timescales that make the longest human life feel like the brief brightness of a match struck in a very large and very old room. Psychologists often note that a sense of perspective genuinely felt, not merely intellectually acknowledged, is one of the more reliable paths to a quiet mind. Not the perspective of comparison, which involves judgment, but the perspective of scale, which involves only placement. The recognition of where one is and what one is part of, and how that belonging extends in every direction further than thought can follow. In that recognition there is something that resembles rest even before sleep arrives. A settling of the self into the larger thing it has always been part of. A release of the effort to be more present, more important, more resolved than a single night requires. The light continues to arrive, quietly, from everywhere and from the deepest past, passing through the walls, through the dark, through the body resting here as it passes through everything on its long and patient journey to nowhere in particular. And what comes when the distances have been allowed to settle fully into the quiet of the room is something that has nothing to do with the universe at all, and everything to do with the single specific life that is here, breathing gently, growing still, finding its way at last toward the particular rest that belongs only to it. Part 11. What the universe does when nothing is watching. Most of the universe is invisible, not dark in the way a room is dark when the lights are switched off, not an absence that could be remedied by the right source of illumination. Something more fundamental than that, something that does not emit light, does not reflect light, does not interact with light in any way that current instruments can detect. It is there, detectable only through the gravitational influence it exerts on the things that can be seen, bending the paths of galaxies, shaping the large-scale architecture of the cosmos, but it cannot be directly observed, cannot be photographed, measured, sampled, or named with any precision beyond the name scientists have given it as a placeholder for what they do not yet understand: dark matter, dark energy. Together, researchers have found they account for roughly 95% of the total content of the universe. Everything that has ever been seen, every star, every galaxy, every nebula, every planet, every ocean and mountain range and living cell constitutes something closer to 5% of what exists. The visible universe is a small thing held inside a much larger invisible one. Scientists are still exploring what dark matter actually is. The leading candidates are hypothetical particles that interact with ordinary matter only through gravity, passing through everything, including the walls of this room, including the body resting here at every moment in numbers that exceed imagination, without leaving any trace that existing instruments can detect. If the leading theories are correct, trillions of these particles move through any given space each second. through the earth, through the oceans, through the atoms of every living thing, silently, without friction, without consequence that can currently be measured. The universe moves through us as much as we move through the universe. What we understand so far suggests that dark energy, which is something different from dark matter and perhaps even more difficult to characterize, is responsible for the accelerating expansion of space itself. Not just the expansion which has been known since the early 20th century, but the acceleration of that expansion. The universe is not simply growing, it is growing faster. Space itself is stretching at an increasing rate, and the force or property or phenomenon responsible for this is distributed so evenly throughout the cosmos that it has no particular location. It is not in any place. It is in every place equally in the spaces between things in the fabric of space itself. Researchers have no widely agreed upon explanation for what dark energy fundamentally is. The best current description is in scientific terms a placeholder, a label for a measured effect that has not yet been traced to a cause. The universe is doing something that the equations do not fully account for. Something is driving it outward at an ever-increasing pace, and that something is everywhere invisible and deeply persistently unknown. There is a particular quality to genuine scientific unknowing that is different from simple ignorance. It is not the absence of information. It is the presence of a question so large and so carefully defined that its edges become visible not the answer, but the precise shape of what is missing. Scientists working at the frontier of cosmology carry questions of this kind the way a person carries a stone in a pocket, present always turned over, sometimes not resolved but familiar. Part of the texture of the work. It may be that the willingness to carry an unresolved question without urgency is one of the more quietly demanding things a mind can do. To sit with not knowing, not as a failure but as a condition, a legitimate place to be. Neuroscientists have observed that the human brain tends to find ambiguity uncomfortable. There are neural systems specifically devoted to resolving uncertainty, to finding patterns, to completing incomplete information, to converting the open-ended into the concluded. This tendency is in most circumstances enormously useful. It is part of what allows the mind to navigate a complex world without becoming paralyzed by the incompleteness of any given situation, but it comes at a cost. The same drive toward resolution that makes the brain an effective problem solver also makes it reluctant to rest in uncertainty. It wants to know. It reaches for answers even when answers are not available. It constructs explanations for things that have not yet been explained, filling in gaps with whatever material is nearest to hand. The brain tends to resist the open question, even when the open question is the most honest available position. And yet the universe does not share this reluctance. It holds its unknowns without apparent distress. The dark matter moves through galaxies and through living rooms and through the atoms of sleeping children with complete equanimity, not because it has resolved the question of what it is, but because the question for it does not arise. Things exist without knowing that they exist. The universe unfolds without needing to understand its own unfolding. Psychologists often note that the ability to tolerate ambiguity, to hold uncertainty, without immediately reaching to resolve it, is associated with a quality of mind that tends over time to be both more accurate and more at ease. More accurate because it does not rush to conclusions that the evidence does not support. More at ease because it does not expend energy, maintaining a position of false certainty against the persistent pressure of a complicated world. The universe in this sense may have something to teach. Not as a lesson, nothing so deliberate, but as a model. The cosmos holds 5% of its content in the visible, and 95% in the unknown, and it does not appear to find this arrangement troubling. It continues its slow and extraordinary work regardless. The galaxies form, the stars burn, the light travels, the expansion continues, all of it proceeding without resolution of the deeper questions in the same quiet and unhurried way it has always proceeded. Evidence suggests that the large-scale structure of the universe, the arrangement of galaxies and galaxy clusters, and the enormous voids between them bears a resemblance in its broad topology to certain biological structures. The cosmic web, as researchers have called it, consists of long filaments of matter connected at nodes, separated by vast regions of relative emptiness. When images of this structure are placed alongside microscopic images of neural tissue or of certain cellular networks, the visual similarity is striking enough to have generated genuine scientific interest in whether similar organizational principles might operate across vastly different scales of physical reality. Scientists are still exploring whether this resemblance is more than visual, whether there are mathematical principles governing how networks self-organize under the influence of gravity or diffusion, or some other distributed force that produce similar geometries regardless of the scale at which they operate. The question remains open, but the image itself, the cosmos and the cell arrayed in similar patterns of node and filament and open space, carries something worth holding gently. The structures that organize the universe and the structures that organize thought may rhyme with each other across a distance that has no meaningful unit of measurement. Researchers studying the formation of large-scale cosmic structure have found that the voids, those enormous regions of relative emptiness between the filaments, are not truly empty. They contain small numbers of galaxies, faint and scattered, and they are threaded with residual magnetic fields and faint streams of gas moving slowly between denser regions. The void examined carefully turns out to have a texture, a subtle low-density life of its own, something happening even in the most apparently vacant expanses that simply requires more careful looking to perceive. It may be that emptiness in this universe is always relative, always a matter of resolution, of how closely one is willing to look, and with what instruments, and with how much patience. The mind quietly registers something similar in its own quiet hours. The moments that seem from the outside most vacant, the long drift of a sleepless night, the formless reverie before sleep, the particular blankness of a mind that has stopped actively thinking are not as empty as they appear. Something is happening in them. Some processing, some reorganization, some slow movement of material from one arrangement to another that the waking attending mind would never permit. The void in neural terms has its own texture, its own low-density life proceeding in the intervals between thoughts. What we understand so far suggests that these intervals are not wasted, that the brain's apparently dormant moments carry functions that the active moments cannot, that the capacity to do nothing, genuinely nothing, without filling the nothing with effort or vigilance or the management of attention, is a capacity that serves the mind in ways that are only beginning to be understood. The universe does not apologize for its invisible content. It does not explain the 95% that cannot be seen or measured with current instruments. It simply continues holding its unknowns, lightly organizing itself around principles that will one day perhaps be understood and are in the meantime simply true. There is a rest that belongs to this kind of patience. Not the rest of resolution, not the exhale of a problem solved or a question answered, but the rest of a mind that has set down the requirement for resolution. That has allowed the open question to be open. That has found in the not knowing something more spacious than any answer could have provided. The dark matter passes through as it always does. The universe expands as it always has, and the person lying here made of the visible 5%, the ordinary luminous matter that stars forged, and gravity assembled into this particular improbable arrangement, rests within all of it, inside the known and the unknown equally, part of a structure so large that its edges have not yet been seen, and so intimate that it reaches all the way down into the spaces between the atoms of a single hand resting on a single blanket in the quiet of a single night. And what comes after this, what the body moves toward now as the mind grows softer, and the distances grow easier to hold, is not something that can be approached by thinking about it. It arrives as most of the best things do in the space that opens when the thinking at last has been allowed to pause. There is a kind of darkness that is not the absence of light. It is something older than light, something that existed before the first photon was ever released, before the first star ignited in the long silence of the early universe. A darkness that is not empty, but full of potential, full of the unformed, full of everything that has not yet become anything. Physicists have a name for the energy that permeates this darkness. They call it dark energy, and it is by current measurements the dominant constituent of the universe, not matter, not light, not anything that can be touched or seen or detected in any ordinary way. An energy woven into the fabric of space itself, present everywhere, and in equal measure causing the universe to expand not at a constant rate, but at an accelerating one. The galaxies are moving apart faster than they were 1 billion years ago, faster than they were 1 million years ago. The universe is not slowing towards some eventual equilibrium. It is rushing gently toward a future that grows larger with every passing moment, and no one knows why. Researchers have calculated that dark energy accounts for roughly 68% of the total energy content of the observable universe. Dark matter accounts for roughly 27%. Everything else, every star, every planet, every ocean and mountain and living cell, every person who has ever existed or will ever exist, every thought that has ever been thought, and every feeling that has ever been felt, all of that comprises approximately 5% of what is out there, 5% of what can in some sense be accounted for. The universe is in its overwhelming majority made of things that remain beyond current understanding. There is something in that which could feel unsettling if held in a certain way. But held differently, held lightly, the way one might hold a very old and delicate thing, it feels like something else, like openness, like the recognition that the story of the universe is nowhere near finished, that what has been understood for all its extraordinary richness and precision is a small illuminated region in a much larger darkness, and that the darkness is not threatening, it is simply patient. It has been patient for 14 billion years. It will continue being patient for whatever comes after. Scientists are still exploring the nature of dark energy, whether it is truly constant as the current best models suggest, or whether it varies subtly across space and time in ways that instruments have not yet been sensitive enough to detect. Some researchers have proposed that what appears to be dark energy might be better understood as a property of space itself, not something in space, but something that space does when given enough room. An inherent tendency of emptiness to expand, a restlessness at the very bottom of the physical world so fundamental that it cannot be separated from the geometry of existence. The universe, it seems, cannot help but grow, and life within it cannot help but follow rhythms older than itself. The rhythms of light and dark that governed single cells before there were organisms complex enough to sleep. The chemical tides that moved through ancient oceans long before there were bodies to contain them. The electromagnetic hum of a planet that has been generating its quiet frequencies through every night that any creature has ever spent in rest. All of it continuous, all of it present, all of it surrounding the small warm fact of a body lying still in a dark room, breathing slowly, growing quieter with each passing minute. Evidence suggests that the universe tends toward greater complexity over time, that the arrow of cosmic history points, however unevenly and however slowly, in the direction of more structure, more organization, more intricate arrangements of matter and energy. And yet within that broad tendency at every scale there is also the opposing motion, the release, the return to simplicity. Stars form and eventually go dark. Civilizations rise and grow quiet. Days fill with complexity, and then one by one the lights go out and the hours simplify, and the world contracts to this: a room, a body, a breath, the in-breath, and the out-breath, and the pause between them growing wider. Neuroscientists have observed that the brain in its deepest stages of sleep produces slow waves of electrical activity that move across it like long swells on a calm sea. These waves, delta waves, the slowest of the sleep frequencies, are associated with the most restorative phases of rest. The body's most vigorous repair work happens beneath them. Memory consolidation deepens within them. The self as a coherent narrative entity dissolves almost entirely during them, leaving something that is still alive, still breathing, still warm and present in the room, but no longer assembled into the particular shape of a person with a history and a set of concerns. Just a body, just breath, just the slow and ancient work of being alive. The mind quietly registers at these depths almost nothing, and in the registering of nothing something essential is restored, something that the waking hours spend down grain by grain, and the sleeping hours fill back up, not through effort, not through intention, but simply through the willingness to be still long enough for the filling to happen on its own, long enough, still enough, quiet enough. The universe expands in every direction at every moment without effort. The stars that are still burning continue their slow nuclear work, fusing hydrogen into helium in their cores, releasing the light that will travel for years or centuries or millions of years before it reaches anything capable of receiving it. The Earth turns on its axis at the same rate it has turned for 4.5 billion years, carrying this room, this building, this body through the dark half of its daily arc. Everything continues. The breath slows. The waves in the brain grow long and low. The minerals in the blood move through their quiet circuits. The body held by gravity, held by warmth, held by the accumulated stillness of the night, does what it has always known how to do. The thoughts, if there are thoughts, are not thoughts exactly. More like weather, something that passes through without needing to be followed. The room is the same room it was an hour ago. The dark is the same dark. The body is the same body. And somewhere just beyond the edge of attention, beyond the last soft boundary, between waking and not waking, something opens. Not a door, not a destination, just an opening, wide and still, and already very quietly there.